Geotechnical Engineering Part 1, Soil Consistency. Today we'll be discussing about consistency limit determination and different indications. Consistency meaning is termed that which is used to describe the degree of firmness of soil in qualitative manner by using descriptions such as soft, medium, filled, firm, stiff or hard. Generally, this degree of firmness in soil is the measure of moisture content in the soil. It is relative ease with which a soil can be formed. Property of consistency is associated only with the fine-grained soil. Mainly moisture content directly depend upon the soil consistency. This degree of firmness depend upon water content. So here you can see in the graph, while increasing the water content, solid state to semi-solid state, and then semi-solid state to plastic state, and plastic state to the liquid state. So this water content also denote the consistency limit. So let us understand the three stages: liquid stage, plastic stage and shrinkage stage. When a fine particle is mixed thoroughly with a large quantity of water, the resulting suspension is in a liquid state, no resistance to flow. In this stage, no shear strength will be available. Second one is plastic stage. Water content of soil, the suspension is gradually reduced to keep the consistency of sample uniform. A stage comes when it just offering resisting to flow. So it will resist the flow, the amount of water added to the soil, and the soil resists to flow. In this stage is plastic stage. Small amount of shear strength will be available in the plastic stage. The third one is shrinkage stage, where lesser amount of water is added. In this stage, small amount of shear strength will be available. Now let us talk about the Atterberg limit. Liquid limit, first one, water content in percentage at the point of transition of plastic to liquid stage. So this transition from plastic to liquid stage is said to be the liquid limit. So in this, soil behaves as a liquid material. In plastic limit, the percentage water content at a point of transition from semi-solid to plastic stage. Here the soil behaves as a plastic material. Now in shrinkage limit, water content in percentage at a point of transition from solid to semi-solid. Here moisture content at which no further volume change occurs, with further reduction in the moisture content. So how to determine the liquid limit, plastic limit, shrinkage limit? Let us discuss first the liquid limit. What are the needs of liquid limit? So generally liquid limit is significant to how the stress history and general properties of soil meet with the construction. Here results of liquid limit, the compression index may be estimated. Also this compression index value will help us in settlement analysis. If the natural moisture content of the soil is close to liquid limit, the soil can be considered as soft. If the moisture content is less than liquid limit, the soil can be considered as soft, and where the liquid limit moisture content is less than liquid limit. So it depends upon the moisture content. Soil is brittle and stiffer. So more water content, more will be the liquid limit, more will be the soft stage. Less liquid limit, metal may be brittle or stiffer. Again lesser water content, which may be the hardened state. Cassegrain apparatus is used to determine the liquid limit. Here you can see a cup is placed on the base where there are handles to give the number of blows in the cup, spatula to cut the sample in the cup, here to determine the liquid limit. 150 gram of dry soil is taken and sieve through the 40 number sieve. Add 20% of water. Then this Cassegrain apparatus is placed and sample is placed on the Cassegrain apparatus, cutting the groove of 2 mm at the base. Now number of blades are counted by running the device. Stop the groove in the soil close to the distance of 12.7 mm. Take the sample and find the moisture content. This test is repeated for 3 times. We need moisture content and number of blows. Now for 25 blows, determine the moisture content. This moisture content will gives you the liquid limit. So graph between the water content and number of blows determine the liquid limit. Here the curve obtained is flow curve and water content at 25 blows is noted. This will be the liquid limit. Here you can see the calculation, quantity of water and number of blows. Flow curve for 25 blows will be getting the liquid limit. Now for plastic limit test, generally to measure the plasticity, soil is used to make bricks, tiles, soil cement block. So we need to determine the plastic limit. Here also 20 gram of soil is being taken and sieve through 40 number sieve. Add water and mix thoroughly. Prepare several ellipse shaped soil mass by squeezing the soil with your hand. Put the soil in a rolling device. Roll the soil until the thread reaches 3.2 mm. Continue rolling until the thread crumb into several pieces. Determine the moisture content. Here you can see small ball shaped sample is being prepared. Then thread of 3.2 mm. Then this sample is kept in the oven to determine the moisture content. Observation, reading, dry soil weight, empty container weight, wet soil weight, again drying weight of soil, determining the water content. Now what is plasticity index? Liquidity index minus plasticity index gives you the plasticity index. So after performing the liquid limit, plastic limit is performed, and then plasticity index is noted. 0 indicates that no plasticity, less than 7 indicates low plasticity, 7 to 17 indicates medium plasticity, and greater than 17 indicates high plasticity. So this table shows the value of plasticity. Shrinkage limit. To determine the shrinkage limit, calculate the shrinkage ratio for a given soil. So here loose soil moisture either in its natural environment or by artificial means in laboratory. It changes from liquid stage to plastic stage, or from plastic to semi-solid stage, and then to solid stage. So this volume changes occurs with change in the water content. But this is a particular limit at which any moisture change does not causes volume change. So this volume change we need to find, that is shrinkage limit. So soil undergoing large volume changes with change in the water content may be troublesome. So volume change may not be will not be equal. Liquid limit test should be performed on a soil. Obtain a quantitative indication of how much change in the moisture can cause or occur before any appreciable volume change occurs. So this indicates the change in volume. The shrinkage limit is useful in the area where soil undergoes large volume change. Then going through the wetting drying cycle, generally in the earthen dam. Here you can see the apparatus of shrinkage limit determination. Here you can see evaporating dish where mercury is being filled, and dry soil pat is kept in a container where mercury is being displaced. So you can see the before shrinkage shape of the wet soil and after shrinkage dry soil volume change from the figure. Now here 50 gram of soil passing through 425 micron sieve. Using the distilled water, make a creamy paste. Required mix water content is somewhat greater than the liquid limit. Coat a thin layer of Vaseline inside a shrinkage disc and wait. Fill the disc in 3 layers of soil paste. The last layer should stand above the rim. Weight the disc full of wet soil immediately. Dry in an oven of 105 to 110 degrees Celsius temperature. Remove the dry bed from the disc, clean and dry the shrinkage disc and determine the mass, empty mass. This weight of empty mercury weight disc also. Keep the shrinkage disc in a large porcelain disc. Fill it to the overflowing with mercury. Transfer the content of shrinkage disc to the mercury weighting disc. Place the glass cup in a large disc. Fill the overflowing with the mercury and remove the excess, pressing the glass plate. Place the tripod on the surface of mercury and submerge it. The transferring the mercury displaced by the tripod to the mercury weight disc and weight. So this mercury transfer to the container will gives you the weight of displaced mercury. So in the calculation, first of all, weight of shrinkage disc W1. This shrinkage disc contain wet soil, that is W2. Now weight of wet soil in shrinkage disc, that is W2 minus W1. Now weight of shrinkage disc plus dry soil, that is W3, and weight of dry soil pad, that is W3 minus W1. Now we need to get the volume of wet soil, that is volume of shrinkage disc, that is V1, and volume of dry soil pad, that is V2. Using the shrinkage limit formula, we'll be getting Ws, and finally we'll be using it to find the shrinkage ratio, that is Ws divided by V2 density of water. And finally volume change we can find out using V1 minus V2 divided by V2 into 100. Different indicates. Here you can see plastic index will give you by liquid limit by plastic minus plastic limit. Shrinkage index by plastic limit by minus shrinkage limit. Liquidity index, moisture content minus plastic limit divided by plasticity index into 100. Consistency index, liquid limit minus moisture content of natural soil divided by plasticity index into 100. So here you can see liquidity index plus plasticity index. Using this we can determine the consistency. So here semi-solid state, very stiff state, very soft state, and liquid state. Different liquid limit and consistency index are being shown. If you sum up, which will be always 0. Flow index W1 minus W2 divided by logarithm of N2 minus N1. Here W1 is the weight of dry soil minus weight of wet soil, and N2 and N1 are the number of blows in the liquid limit. Flow index is the slope of flow curve. Using this we can get the toughness index, that is IT, that is plasticity index divided by flow index. This toughness index can determine the strength of soil, that is specially shear strength of soil. Thank you for listening. Thank you.